Here we have what are called two simultaneous equations. Now, simultaneous equations are equations that we need to solve simultaneously, which means at the same time in the same number space. So what we're looking for is two solutions to the variables x and y that are equal for both equations. Now, these come from what are called systems of equations. And the system of equations rule is that for every unknown or variable, you need an equation. Here we have x and y, so we have two equations for solving two variables. Now, what we normally do when solving an equation is we have an equal sign and one unknown, so an x or a y. But here we have two of them, so it makes it very difficult to solve it using this traditional method. So what we do is we need to eliminate one of the variables. Now, to do that, we look at the coefficients in front of the unknowns. So the unknowns are x and y, so we look at the numbers in front of them, and we look at the signs as well. Okay, now what we're trying to do is find numbers, coefficients that are the same. So x is 2 and 5, they're not the same. Y, they're both positive 3s. So because of that, we know we can eliminate the y's. And we do this using a little technique that you haven't seen before, but once you see it, it's very simple. So what we do is we say, okay, I know that both of these equal 3y, or both of them have a 3y in them, so I'm going to let them both equal 3y. So I'm just going to use a simple skill I already know called rearranging, and I'm going to put 3y on one side of the equations. Okay, like this. Now, for the first one, a, we have a 2x on there. So we need to move the 2x to the other side. When you move a term to the side, the sign changes. So we'll end up with, there's the 9 that's already on the right-hand side, and this becomes negative 2x. For equation b, we have a 5x we need to move. It's a positive 5x, so if we move it across, it's going to become negative 5x. We already have an 18, so now we have negative 5x. The reason we've done that is so that we have the same terms on one side. So if 3y equals 3y, which it patently does, then 9 minus 2x has to equal 18 minus 5x, since they both equal each other. That allows us to take this down here and write a new single or combined equation, because we know that these have to equal each other, since 3y equals 3y. And now we've got an equation, and it only has one unknown, which is something you should be more familiar with, and we can solve it. So our first step is, which is the smallest value of x? We have a negative 2x and a negative 5x. The negative 5x is the smallest, so we're going to move it to that side of the equal sign. We only want x's on one side, so we need to move whatever's not an x, which in this case is a number, onto the other side. That gives us 5x minus 2x equals 18 minus 9. And now we can solve it. 5x minus 2x equals 3x. 18 minus 9 equals 9. We've got 3x's, we only want 1x, so we divide by 3. Divide this side by 3. Divide the other side by 3 to balance. It gives us 3. And there's our first answer. X equals 3. Now, to find the second variable, y, we need to substitute our newly found value of x into one of the equations. Now, always use one of the equations they give you. So I tend to use the simplest one of the two. Sometimes it's hard to tell. It doesn't matter which one you use, but the simplest one makes it usually a bit easier. So I'm going to use equation A, and I'm going to bring it down here and combine it, the value x equals 3. So if I do that, I have 2. Instead of 2x, I know x is 3, so I put 3 there. Then I've got my plus 3y equals 9, okay, which means I can now solve it. So I can multiply out the 2 times 3, which is 6. 6 plus 3y equals 9. So take away 6 from both sides. 3y equals 3. Divide by 3, so y equals 1. And there is my second solution. So the solutions to these simultaneous equations are x equals 3 and y equals 1. Now, the example we did before, we had coefficients that were the same sign and the same number, so they're quite easy. But often we get equations, simultaneous equations, where that isn't true. So if we look at these ones, the coefficients we have a positive 4 and a positive 3, and we have a positive 5 and a negative 2. Now, because of that, we can't do what we did last. What we need to do is make them the same. Now, you can pick which pair you want to make the same. Okay, and by that I mean what's the lowest common multiple, what number can you make both of them into. So 4 and 3 we can make into 12. Plus 5 and negative 2 we can make into plus 10. Now, normally I'd use the 4 and the 3 because the signs are the same here, but I just want to show you how you do ones with different signs. It's the same method, it doesn't make a difference. So we're going to try and eliminate the y's by making the coefficients of the y's positive 10. Okay. Now, to do that, we need to multiply. So to make positive 5 into positive 10, we're going to need to multiply by 2. Okay, because plus 5 times plus 2 gives us plus 10. For the second equation, the b equation, we need to multiply by negative 5 because negative 2 times negative 5 gives us our positive 10. Okay, now when we say multiply, if we're going to multiply one term in an equation, we have to multiply all of them to balance the equation out, to keep it in proportion. Okay, so when you do this multiplication, you must multiply every number that's in that equation. Okay, so the first one, we've got 4x, we need to times that by 2. So that gives us 8x. Plus 5y times 2 is the plus 10y that we want, equals negative 7 times 2, negative 14. Okay, so all three numbers are being multiplied by that multiplier to keep it balanced. Same with equation b, so negative 5. So 3 times negative 5 is negative 15x. Negative 5 times negative 2y is the positive 10y we wanted. And 12 times negative 5 is negative 60. And as you can see, we've now got what we wanted. Okay, two variables that are the same. They have the same coefficient with the same sign. So now, if you remember from our last step, we just want those terms on the same side. So we move or rearrange the equation. So we want the 10y there. There's an 8x on the left-hand side. Move it across the other side where there's already a negative 14. So the 8x, positive 8x becomes negative 8x. And here we've already got, there's our 10y. We've already got a negative 60 on the right-hand side. We're going to move the negative 15x across, and that becomes positive 15x. Okay, as we did in the example before, one side, left-hand side, is now exactly the same. If they're equal on the left-hand side, these have to be equal on the right-hand side. And so we can now create our single equation. Okay, so negative 14, take away 8x, equals negative 60 plus 15x. All right, now we've got our equation. It only has one variable, x, and we can solve it as we normally do. So first step, which is the smallest x value? So the negative 8 is smaller than the positive 15. So we're going to move that to the right-hand side. And we need to move this negative 60, which is a number, to the left-hand side. Rewrite that equation then. We have negative 60 move becomes positive 60. 60 take away 14 equals 15x plus 8x. 60 take away 14 is 60, 50, 46. And 15x plus 8x is 23x. Reflect it around and divide by 23, and that gives us x equals 2. And there is our first solution. Then go and pick one of the original equations they gave us. Always pick an original, not one you've manipulated, just in case you make a mistake. Pick the simplest one. Here it doesn't really matter. Depends what you like doing. So I'm going to pick b. So I'm going to bring b down here, and I'm going to combine it with x equals 2. So that gives me 3x, but we know x is 2, minus 2y equals 12. So that's 3 times 2 is 6. 6 take away 2y equals 12. So negative 2y equals 12 take away 6, which is 6. We want y on its own, so we divide by negative 2. So that gives us negative 3. And there is our second answer. So the solutions to these simultaneous equations are x equals 2 and y equals negative 3.